So the next thing we are doing with vectors is called the dot product. Okay. So on Thursday and Friday, we talked about how to add vectors and do what's called a scalar multiple and combine them that way. And that was all fine. But when we did that, we actually got a vector. Right. When we do this thing called a dot product actually results in just a normal number. It's not, so your answer when you do the dot product is not a vector. It's just what's called a scalar. It's just a plain number. It can be negative, it can be positive, it can be zero. That's a special case we'll talk about in a second. But it's just a number. Okay. And then once we know how to find the dot product, we can use the dot product to do a couple other things, which again, we'll talk about those two things in a couple minutes. Okay. So what is the dot product? Well, it's notated by, go figure, dot. So if you see a vector dot another vector, that's what it means. That's our dot product. And all we do is we multiply the x value. So notice, just in my kind of general case here, if v is a comma b, and w is c comma d, then we find the dot product by multiplying the x's, multiplying the y's, and adding them together. That's it. So multiply the x's, multiply the y's, and add. All I can say about that is just watch your signs, watch your arithmetic, and go from there. So let's kind of jump in here. So the first five, notice I've got 5 vectors up here, and I tried to show a little bit of school spirit in a math classroom. So my 5 vectors spell out husky. So I'm going to do the first 2. I don't know if you guys do the other 3, just for a quick little bit of practice on making sure you're combining the right things and getting the right things. And then we'll go on to see how we can use the dot products. So S and K. S dot K is literally how you would read that. So again, we multiply the x's. So this would be 5 times 1 plus 5 times or 10 times negative 6. And then just figure out what it is. So that's 5 minus 60, which is negative 54. Again, a negative number is fine. Positive number is fine. 0 is fine. Whatever it comes out to be. And that is your answer. That's if it's just asking for the dot product, that answer, and you're done. What the dot product tells you basically, it's kind of the beginning point of telling you how far apart the vectors are, if that makes sense. It helps us find the angle between the 2 vectors. And it can do a couple of things in physics land also, which we'll get to that in a second. That's the whole thing about the dot product. That's it. So let's do one more example. And again, I'll let you guys do 3, 4, and 5 on your own, just to make sure we're getting the right numbers. So y and u. So we're taking these 2 vectors here. The nice thing about the dot product too, the order actually doesn't matter. So if you did y dot u, it'd be the same thing as if you did u dot y. Doesn't matter. The order doesn't matter. It is commutative, is what we call that. But I'm going to do it in that order just so nobody gets kind of turned around. So again, multiply the x's, 12 times negative 3. And then multiply the y's, 2 times negative 3. So that's negative 36 minus 6, or plus or negative 6. I already want to write that. But it comes out to be negative 42. And that is your dot product. So I'm going to give you guys about, I don't know, 3 minutes, something like that. Give you guys about 3 minutes. You can just look up on screen, jot them down on a piece of scratch paper in your notes, whatever. Find the dot product of h dot s, n dot h, or sorry, u dot h, good heavens, u dot h, and y dot k. And we'll come back and check those real quick, and then we'll go in to see how we can use the dot product to find the angle between two vectors. If you get those answers, you can send them in the chat box. That would be cool. Again, we're multiplying the x's, multiplying the y's, combination, and then add them together. Then whatever you get is what you get. That's your dot product. My chat box is lonely and quiet. Give you another minute or so. I'll hold out hope that I get some answers. Oh, there's one. Hope, maybe. Possibly. So Monica, make sure that you are keeping track of your x's and your y's, and getting the right vector there. So make sure you, like on number 3, make sure you're using H and S. So let's take a look at number 3 here. So we got H and S, so we got this vector and this, so and that one. So again, we multiply the x values, so it'll be -4 times 5. And then multiply the the y values. So combine that with 2 times 10. So that's -20 plus 20, which is equal to 0. So the dot product on number 3 would be 0. Or I'll put the 0 there, sorry. This is actually a special case. And I got a fancy word for you. So you can impress your friends and impress your parents later on. So when the dot product is equal to 0, we call those two vectors orthogonal. Orthogonal is really just is a fancy word for perpendicular. It's not exactly the same, but in two-dimensional space, which our vectors are going to be, in two-dimensional space, it is the same. They become slightly different when you go into higher dimensions, if you go into 3 dimensions in particular. But for our purposes, if the dot product is 0, then the vectors are going to be perpendicular, which I think you know what that means. How about number 4? Number 4, yeah, Monica, you're good on that one. And number 5, Mandy, you're good on that one. Yep. So number 4, again, dot product, U and H, these two guys right here. So -3 times -4. And then the X is -3 times 2. That becomes 12 minus 6, which is just plain old 6. That's the dot product. And then when you do Y and K, you end up getting 0 again. 12 times 1 plus 2 times -6. 12 minus 12 is 0. So that's going to be orthogonal as well. So that is the dot product. I'm going to give you guys another short assignment. I've been trying to do like super short assignments, hoping that since they're short, we'll do them and get them done. But it's going to be another short one tomorrow on just finding the dot product and a couple things, and then find the angle between two vectors, which we're getting ready to do, and then a little bit on work, which will be the last one I'll show you. So once you know the dot product of two vectors, you can use the dot product to then find the angle between those two vectors. There's a longer way to do it. You know, if you found the direction angle of, like, if you do a number 1, you can find the direction angle of just vector S by what we did on Thursday, Friday, and then find the direction angle of just angle K, and then subtract those two numbers, and you get the angle between those two vectors. But there's kind of a shortcut. If you know the dot product, you just have a single formula to find the angle between the two vectors. And that formula is, it's the inverse cosine of the dot product over the product of the magnitudes. So remember, those two double bars means magnitude. So once you know those three things, then we just pop it in the formula and we're done with it. So S and K, notice I did use the same 5 pairs of angles in these guys, so we would have to kind of do double the work. So the S dot K, I already have that. So S dot K is -54. But I have to find the magnitude of S. And if you remember from Thursday, Friday, the magnitude isn't anything more than the square root of the sum of the squares. So for vector S, right here we go, the magnitude would be 5 squared, 25, plus 10 squared, 100, add those together. So it's the square root of 125. Do the same thing for K. 1 squared is 1, -6 squared, 36, add them together. So the magnitude of K is 37. And now it's all down to Desmos. So we know the angle between those two vectors is the inverse cosine of the dot product on top and then the two magnitudes. The only thing you got to be careful about when you're putting this into a calculator or into Desmos or whatever is make sure you're doing 2 individual square roots on the bottom. And you're not kind of getting a square root inside of a square root, stuff like that. So make sure you separate those out with the times. And then once you put that in, you should get an answer of 142.56. If anybody wants to see me put that in Desmos, I'll be happy to show them. But again, you just want to have it look exactly the way it looks right here. You don't have to do anything. You don't have to, I don't care about what root 125 is or root 37 is a decimal. You just type it into Desmos or any calculator that way, and it'll spit out the answer. As always, let's try to go to 2 decimal places, and that'll be sufficient. Okay, so find the dot product, find your 2 magnitudes, plug and chug, and there you go. So I'm going to do number 7. Same pair here. So again, we already know the dot product. Y dot U is -42. That kind of rhymes. Magnitude of Y. So we got 12 squared plus 2 squared, 148. So square root of 148. And the magnitude of U, 9 and 9, so root 18. And to find our angle theta, inverse cosine, dot product on top, magnitudes on the bottom. Again, keep them separated. Pop it into Desmos, and you get 144.46. It's actually similar by accident to the first one, but they are different. They're off a couple degrees, but that's okay. So last ones, and then there is one more application I'm going to show you guys of the dot product using a physics quantity called work, which you guys are probably familiar with because you're in physics or have had physics. But take a few minutes. I'm going to give you like another 2 or 3 minutes. Practice using Desmos. Find the dot product, which you already did. So H dot S. I'm going to let you guys do this. I'm just going to do the first 3 things. So H dot S, we already found it was 0. By the way, since you know the dot product is 0, you can actually skip this work and just write what the angle is if you remember what perpendicular means. If you don't remember what perpendicular means, then you got to do the work. Magnitude of H, magnitude of S, and then you can find your theta. So do the same thing for 8, 9, and 10. You can see 9 and 10 down at the very bottom of the screen. And I'll leave it here so you can still see those vectors on top. So you can just kind of jot down the answers. And you can put them in the chat box and we'll come back together and check these guys and then go on to work for a second. All over. If you remember what perpendicular means, number 8 and number 10 will take you about 10 seconds. Even if you don't remember, when you find 8, it's going to be the same thing as 10 because they have the same dot product. That'll only work if they're both 0. And remember, magnitude, the square root of the sum of these squares. So H and S, what's magnitude of H? -4 squared, 2 squared, 16 and 4. So magnitude root 20. For S, we already had that figured over here, so but it's 125. But if it's 0 over whatever, that's going to be 0. So the inverse cosine of 0 is 90 degrees, perpendicular from your geometry days. So whenever you see the dot product is 0, it's automatically your angle between those two things is 90 degrees. You don't have to do any work because that's what orthogonal means. Okay. Let's do number 9. Oops. Hector, did you get 0 for the angle or the dot product? If you got 0 for the angle, make sure that you're using inverse cosine. You might have used inverse sine accidentally. But make sure you're using inverse cosine. Yeah, so remember, so it's the inverse cosine, right? So when you put it in Desmos, let me show you what it looks like in Desmos real quick. Oops, wrong one. There it is. So you put it in Desmos, it's gonna look like this. This is the first one we did. So to get that cosine inverse, the little functions key, cosine inverse, make a fraction. And for like number 8 there, it's root 20 and root 125. So it'd be 0 on top, square root of 20 times square root of 125. It would end up looking like that. But whatever the numbers are, again, just make sure that using inverse cosine, big parentheses, separating out the square roots. Hector, did you see what you're kind of missing there? Okay, perfect. Okay. And again, if the dot product is 0, then your angle is automatically 90 degrees. That's just what happens. Okay. But if it's not 0, then you got to do everything else, right? So number 9 for U and H. So the magnitude of U was -3, so that's root 18. And the magnitude of H was root 20. So again, inverse cosine of the dot product 6 on top, root 18 times root 20. And you pop that into the calculator and you should get 71.57. Okay, so that's the angle between two vectors. Just find the dot product, find the magnitude, and pop it into the calculator. Now, the last application I'm going to show you the dot product is from physics land, and you guys have, and some of you guys are either currently in physics or you've already had physics, but this is a way that we can find work, the actual physical quantity of work. Okay, and it's just this form right here. So work is equal to the dot product of the force vector and the vector that shows the motion of the object. A lot of times that's given between 2 points, like on a coordinate plane almost. And that's how you can determine work. Okay. The catch on these kind of problems is physics people like that IJ notation. If you remember from Thursday, Friday, we talked about the unit vectors I and J, where I is the vector 1, 0, and J is the vector 0, 1. So like on this first example here, if your force is given as 75I, that just means I can write that as 75, 0, because I is 75, J is there's not even there, so 0. So that's the same way of writing that vector there. Physics loves IJ notation. Don't ask me why, because I don't know. Ask Martinez or Gossman. But then your PQ vector, again, usually it's saying, okay, it starts here, it moves here. So what's the vector going to be? This is what we did on Thursday, Friday also, where we do that end point minus the start point. So if we do 7 minus -4, comma 3 minus -1, oops. And so my PQ vector would be the vector 11, 4. So to find the work, we take the dot product of those two things. So it's the dot product of 75, 0 and 11, 4. And we know how to find the dot product now. Just multiply the x's. So 75 times 11 plus 0 times 4. That's a toughie. 75 times 11 is 825. So that would be your work. Those units are usually in joules, but I'm not a physics teacher, so I'm not too worried about units. I always give physics teachers a hard time. Please don't get me wrong. I like physics, honestly. But I do enjoy giving physics and physics teachers a hard time. Last example, I'm going to turn you guys loose. 30, we got, oh yeah, we only got like 6 minutes anyway. So last one, again, force, IJ notation. Don't overthink it. If you see IJ notation, that's just another way to write a vector. So the force vector is 10, 7. Done. We have to find our motion vector. So again, from P to Q. So it's end minus start. So -3 minus 5. 6 minus -2. Which is -8 and +8. And then to find the work, we take the dot product. 10, 7 dotted with -8, 8. 10 times -8, 7 times 8, -80 plus 56, which is -24. And work can be negative, so that's okay. Whatever the dot product comes out to be. We would probably say that that's actually a work of 24 joules, just in the opposite direction. That's kind of semantics.